We recently had a test in AP Calculus from the limits to normal lines toward the beginning of our calculus course, and we're going to go over these problems of the test. Problem 1, determine which of the following statements are true about the graph of f of x to the right. Circle the correct multiple choice answer. So typically what we do is go and kind of go down a list one by one and see which of these are true and answer A through E accordingly. Well, 1 is the limit as x approaches 1 of f of x equals 2. Well, what we have is the limit is the value that the function approaches at one point from the left and from the right. So if we kind of view this as a fence at x equals 1, we see that from the left and from the right, the value being approached appears to be 1 and not 2. And so this would disqualify 1 and qualify 2 as being the correct answer. Now for 3, the limit as x approaches 1 of f of x equals f of 1. Well, the limit we see is 1, but f of 1 is equal to 2. So therefore the limit does not equal the value of the function, so that is disqualified, and so our answer is B, 2 only. Next, determine whether the function h of x is differentiable at x equals 2. Justify your answer using mathematical notation. And typically what we're looking for in mathematical notation is, first of all, to be differentiable, what do we need first before differentiability? Well, we need continuity. And for continuity, we need to have a limit at this critical value where x equals 2. And so we can set that up. The limit as x approaches our critical number 2 on the left side of h of x is equal to the limit as x approaches 2 from the right side of h of x. And really, that's kind of a question, right? We don't know if it does, but we can set this up and see what happens. Well, from the left side, we have 2x squared minus 4x plus 3. So I'm going to write 2, and in place of x, we're going to place the critical value 2 squared minus 4 times 2 plus 3, and set that equal to the right side, which is going to be negative 3 times 2 plus 9. Now, simplifying the left side, we're going to have 2 times 2 squared, which is 8, and negative 2 times 4 is 8. So we have 8 minus 8 plus 3 equals negative 3 times 2 is negative 6 plus 9. And so 8 minus 8 cancel. So we have 3 equals 3. And since both of these limit from the left side equals limit from the right side, we can conclude that h of x is continuous at x equals 2. Now, we now have to go on to differentiability. That was a necessary requirement for differentiability, continuity. So now we go to differentiability, which again is a limit situation, but this time we have the limit as x approaches 2 from the left side, not of h of x, but of h prime of x, equals the limit when the limit from the left side of h prime of x equals the limit from the right side of h of x, what we'll have is a smoothly joined uh, piecewise function or curves together that there's not going to be any corner. And so doing this, we're going to differentiate the left side. And before substituting, we'll just differentiate first. We say 2 times 2 out front is going to be 4x, and then the derivative of negative 4x is minus 4 equals the derivative from the right side, which is going to be negative 3. And now substituting in 2, we'll have on the left side 4 times 2 minus 4 equals negative 3, and 4 times 2 is 8 minus 4, so we have on the left side 4, and on the right side negative 3. Do they equal each other? No, so we say the limit as x approaches 2 of h prime of x does not exist, dot, 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 h of x is not differentiable at x equals 2. At x equals 2. Now, I had one of my students, Elizabeth, who worked out the right side first and didn't have found that the slopes were not the same, and that we did not have, the limit did not exist, and therefore this function was not differentiable. And so I ended up, after considering, giving her full credit, because she did prove that the function was not differentiable. Now, where she could have gotten in trouble is that if these two had equaled each other, she still could have been wrong if she had not checked the left side. So I just like the progression of going for continuity first, then differentiability. But Elizabeth, that was her strategy, and she sure enough proved that the function was not differentiable at x equals 2. Okay, problem 3. Differentiate each function and simplify answers. Write all answers without rational or negative exponents. And so we have just kind of 4 basic types of differentiations. The first one, g of x equals 7x cubed minus 12x plus pi over 2. Well, g prime of x is going to be equal to 3 times 7, which is 21, x to the power of 3 minus 1, which is going to be squared, minus 12. And the derivative of pi over 2 is a constant, so this will be our correct answer for part A. All right, part B. This time we have v of t equals 4 over t squared minus 5 over 6 the cube root of t squared. And what we're going to do is rewrite this function in what I like to call calculus-friendly form, where we'll write this as 4t to the negative 2 power minus 5/6. We have t, and we have squared and a third root of that, so that's going to be t to the 2/3 power. Okay. Next, let's go ahead and differentiate. V prime of t is going to be equal to negative 2 times 4, which is going to be negative 8. And this time we're going to have it'll be t to the negative 2 minus 1, so that's going to be negative 3 power. And here on the right side, we're going to have negative 5/6 times 2/3, and it's going to be t to the, now this is going to be t to the negative 2/3. I had forgotten this earlier. So we're going to have 2/3 minus 1. So that's going to be differentiate t to the negative 5/3. And next we're going to write this without rational or negative exponents. And so v prime t is going to be equal to negative 8 over t to the 3rd power. And here we have minus, well, that's going to be 10 in the numerator, 18 in the denominator, so we're going to have minus, but when we multiplied through this negative 2/3, that would be a negative times a negative, so that's going to be positive 5/9, and we're going to have t to the negative 5/3, well, that's power. We're going to have the 3rd root of t to the 5th power. So this is going to be our answer for v prime of t. Next, we have b, which is what we have is we call the product of two functions, and really it's kind of a organization. We're going to let this 3x equal u, this quantity 2x minus 1 to the 4th power v. And so we'll say u prime equals the derivative of 3x, which is 3, and v prime, well, that's going to be a little more involved. We have, using the chain rule, 4 out front times 2x minus 1 to the 4 minus 1, which is 3, and then times the derivative of the inside, which is going to be 2, and simplifying out, we're going to have 8 times quantity 2x minus 1 cubed. And so having u prime, v prime, we can go for y prime, and y prime equals v prime, so u is 3x, so I'm just going to write 3x, and v prime is times 8 quantity 2x minus 1 cubed plus v u prime. Well, u prime is 3, and v is quantity 2x minus 1 to the 4th power. And just kind of combining things here, 3 times 8, that's going to be 24x times quantity 2x minus 1 cubed plus 3 times quantity 2x minus 1 to the 4th power. That's going to be y prime. Okay. Now, that's going to be right here. Now let's look at problem D. We have S of t equals 2x minus 1 over 3x plus 5. And for this, we have the quotient of two functions. So we'll call our high function 2x minus 1. The derivative of our high is going to be 2, and low is going to be equal to 3x plus 5, and the derivative of the low is going to be 3. So S prime of t is going to be the low function, and the low is 3x plus 5 times the derivative of the high, which is 2, minus the high function, which is 2x minus 1, times the derivative of the low, which is 3, all over low squared. And low, again, is 3x plus 5 squared. And simplifying out, we have 2 times 3x, that's going to be 6x, and 2 times 5 is going to be plus 10, and 3 times 2x is and minus out front is going to be minus 6x, and we're going to have minus minus here, so we're going to have plus 3 all over quantity 3x plus 5 squared. And we're going to be able to cancel 6x minus 6x, so S prime of t simplifies to 10 plus 3, which is 13, over quantity 3x plus 5 squared. So that's going to be our answer for part D. Basic differentiation problems. Okay, next. Determine the value or values of x for which the function x cubed, y equals x cubed plus 6x squared plus 9x minus 1 has a horizontal tangent line. Well, to do that first, we're going to differentiate this function y equals x cubed. So we'll call it y prime equals 3x squared plus 6x 12x, excuse me, plus 12x plus 9. And to find a horizontal tangent line, we're trying to find the values of x where the derivative will be equal to 0. So we're going to replace y prime with 0, and we're going to factor this trinomial, this quadratic trinomial, by taking a 3 out front. So 3 times quantity x squared plus 4x and plus 3. So we have, we're going to set about solving more by dividing both sides by 3. So we have 0 equals, and now we're going to attempt to factor this quadratic trinomial. So we have x, I think it's going to be x plus 3 times quantity x plus 1. And using the zero factor property, x plus 3 equals 0, and x plus 1 equals 0. So x has to be equal to negative 3, and x is equal to negative 1. This is where these x values are where this function has horizontal tangent lines. So, next, Find each of the following limits. And here we have a piecewise function g of x equals x plus 4 over x squared minus 16 when x is less than negative 4, and negative x over 16 minus 3/8 when x is greater than negative 4. And immediately, for the limit, do we really care about the value of the function? No, we don't. So we can just kind of cross this out and work with what we have left. And so we will say the limit as x approaches negative 4 on the left of g of x equals the limit as x approaches negative 4 from the right of g of x, and just start setting this up. Well, on the left side, we're going to plug in negative 4 for x. So we're going to have negative 4 plus 4 over negative 4 squared minus 16. And on the right side, we're going to have negative 4 over 16 minus 3/8. Well, on the left side, we're going to have negative 4 plus 4 is going to be 0. And in the denominator, negative 4 squared minus 16 is going to be 0. So we have an indeterminate form on the left side. On the right side, we have negative 4 over 16, which is going to be 1/4 minus 3/8, which is going to be equal to 2/8 minus 3/8, which equals negative 1/8. So that's going to be our right side. Our left side, we're going to try to factor this expression out here. So we have in the numerator x plus 4, and if we can simplify, we're going to also have quantity x plus 4 in the denominator, and using difference of squares, our other factor is going to be x minus 4. And we know that x plus 4 over x plus 4 will cancel. So now we can just take, so we'll run here, we can go and substitute negative 4 in here. So we have, cancel, so we have 1 over negative 8 equals, we're continuing to bring down negative 1/8 here, equals negative 1/8. So we have essentially negative 1/8 on the left equals negative 1/8 on the right. So our correct answer is going to be negative 1/8. So let's go on. I don't think the other ones are quite that involved. Now we have a limit as x approaches infinity, which is a horizontal asymptote. And a horizontal asymptote, as we go toward infinity, if you look at the highest coefficient exponent, well, not the highest exponent value of the polynomials, well, we have 3x squared over negative 4x squared. And so in comparison to these higher values, as we go toward infinity, the lesser terms really aren't of consequence. And so essentially what we have is our horizontal asymptote is going to be 3x squared over negative 4x squared. And of course, x squared over x squared will cancel. So we're going to have negative 3/4. That will be our limit as x approaches infinity, which equals our horizontal asymptote. So our horizontal asymptote is y equals negative 3/4. Next, C, the limit is as x approaches 2 of the cube root of quantity 6x minus 4. We're just going to plug in 2. So we'll say equals cube root of 6 times 2 for x minus 4. Well, we're going to have 12 minus 4 is going to be the cube root of 8. And we should know that the cube root of 8 is 2. So 2 is our correct answer. We'll put it over here as well. Okay. Next. D. The limit as x approaches 3 of pi cubed. Well, there is no x to plug in here, and so what we essentially have is we have a function that is going to be y, or f of x, equals pi cubed, which I think worked out in the calculator is going to be 31 point something. So as x approaches 3, okay, or any number, the value of this function is going to be pi cubed. So that is our answer. Kind of a little bit of a trick question, but that's what it is. Okay, next, E. The limit as h approaches 0 of 5 quantity x plus h cubed minus x plus 8 quantity x plus h minus 5x cubed plus x over h. Now this is a definition of a derivative problem, and what this is the definition of a derivative problem is simply the definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. And so knowing that, the function is going to be this x plus h replaces an x in the equation. So the function, now we'll call this f of x, is going to be equal to 5 on the outside, and this is x cubed. And then we have, this is another x plus h, so that's going to be minus x. So that is our original function. And here we verify that because we subtract out 5x cubed here, and we subtract out negative, or and reverse the sign here with this plus x. And so f prime of x, which is the limit as h approaches 0 of this expression on the top over h, is going to be 15x squared minus 1. Now that's just using the power rule, knowing the definition of derivative. So we'll just write down 15x squared here minus 1. But if we really wanted to go hardcore, or we had a teacher who insisted on going hardcore, this is what would have to be done. And what I did is in advance I worked all this out, expanding the quantity x plus h cubed, and came up with all the steps. If you really are dead set on figuring this thing out, you can just pause the video here and go through the paces and show that we ended up with 15x squared minus 1, which is what we had right here by taking our shortcut. Okay, let's go to problem 6. Find the average rate of change of f of x equals negative 3x squared plus 5 over the interval from negative 1 to 3. Now, the average rate of change, which we affectionately have called AROC, average for acronym for average rate of change, is going to be f of b minus f of a over b minus a. Now, this is just a form of the slope formula. And here we have A is going to be -1, B is going to be 3. So A rock over this interval from -3 to 1, closed interval we call it, is going to be f of 3, which we're going to call -3 squared plus 5 minus, and this time I'm going to put in parentheses, -3 times -1 squared plus 5. So that's f of b minus f of a over b, and b is 3, and minus -1. And so simplifying out, we will have, see, 3 squared times -3 is going to be -27 plus 5. And here inside, we're going to have -3 times 1 plus 5. So we're going to have minus -3 plus 5 minus 2 over 4. And so that's going to be equal to -27 plus 5. That's going to be -22 minus 2 is going to be -24 over 4, which is going to be equal to -6. So that's going to be our average rate of change over the interval, closed interval from -1 to 3. There we are. Okay, next, problem 7. G of x equals 1 over x squared plus 2. Write the equation line tangent to the graph of g of x at x equals -1. First, in order to write the equation of line tangent, we need two things. What are they? We need a point and a slope. Well, the point, we don't have the total point, but we have the x-coordinate of that point, which is -1. So if we plug in -1, we're going to be able to get our y-coordinate. So I'm going to put in g of -1 equals 1 over -1 squared plus 2. Well, here we have 1 over -1 squared plus 2. That's going to be equal to 1 plus 2, which equals 3. So that's going to be our y-coordinate. So that helps us out. The next thing we need is a slope. Well, for the slope, we're going to need to take g prime of x, but before differentiating, we're going to go rewrite g of x, as x to the -2 power, and period plus 2. So g prime of x is going to be equal to -2 x to the -3 power, and this 2 zeroes out, so we're going to have -2 over x cubed. And now we're going to substitute in -1, so g prime of -1 is going to be -2 over -1 cubed, which will be equal to -2 over -1, which equals 2, which is our slope. We call m sub t slope of the tangent line. So we'll put slope m sub t equals 2. Now we're going to use our point slope form. Y minus y sub 1 equals m times quantity x minus x sub 1. And that's going to be, in this case, y minus 3 equals m, or the slope, times quantity x minus negative 1, so we'll say plus 1 here, and this is going to be in point slope form. We could go ahead and find the slope intercept form, but this is sufficient right here. Okay, 8. Find the instantaneous rate of change of y equals 1/2 the fourth root of x at x equals 81. And students had a particular interest in this problem. Well, first of all, we're going to rewrite this radical form in rational form. So instead of y equals this radical form, we're going to say y equals 1/2, and this is going to be x. What is the fourth root? Well, it's going to be x to the 1/4 power. There we have rational exponent. So now we're going to differentiate. Y prime equals, we multiply by 1/4, and we have 1/2, and we're going to have x to the power of 1/4 minus 4/4, which is going to be negative 3/4. And combining and writing this function back in a radical form, 1/4 times 1/2 is going to be 1/8. And this x to the negative 3/4 power is going to come down here in our denominator as a fourth root here, and x cubed inside the radical. And now we're going to go ahead and plug in 81 for x. So we'll say y prime of 81 is going to be equal to 1/8. And I'm going to go ahead and put in 81 and make this a fourth root. But I'm going to take all this to the third power. So instead of putting that third power inside of this x, we can put this on the outside. That's maybe not very clear. And it really makes the calculations a whole lot easier to do it this way. So that's the reason for it. Okay. Well, the fourth root of 81 is what number do you multiply by itself 4 times? What times what times what times what? The same number will equal 81. Well, we know that 3 squared is 9, 3 cubed is 27, and 3 to the 4th power is 81. So the fourth root of 81 is going to be 3. And we have 3 to the 3rd power, which equals 1/8 times 27. Well, 8 times 27 is going to be 8 times 25, which is 200, plus 2 times 8, which is 16. So our answer is going to be, our instantaneous rate of change is going to be 1/216. So that's our instantaneous rate of change. Okay, next we go to problem 9. Find the equation of the line tangent to the graph of h of x equals x cubed minus 4x squared at the point where h prime of x equals 3. Now, we're going to find h prime of x. Well, h prime of x is going to be equal to 3x squared minus 2 times 4 will be 8x. And we're trying to find out the equation of line tangent where h prime of x equals 3. So we set h prime of x equal to 3. So we say 3 equals 3x squared minus 8x. And now solving for x, we can just set one side of the equation equal to 0. So we get 3x squared minus 8x minus 3 is equal to 0. And factoring, an attempt to factor anyway, we're going to have 3x times x, and then we're going to have negative 3. Let's see. 3x times x. Well, if we put negative 3 here, x minus 3, we're going to end up with negative 9. And we put plus 1, we're going to get this type of relation. So I think we have negative 3x plus x. So this is going to work. So we have 3x plus 1 equals 0, and x minus 3 equals 0. So we have x equals 3, and we have, if we solve for x here, we'll subtract 1, and we'll have x equals negative 1/3. Now it says find the equation of the line tangent to the graph at the point where h prime of x equals 3. I will be honest with you that I think this deal here is going to be a lot easier where x equals 3 as opposed to using this fraction. Since they're only asking for 1, we can choose. I'm going to choose x equals 3. Well, we have the equation of the line tangent, so we know that the slope, we already know the slope. The slope equals 3. H prime of x equals 3. And the point, well, for the point, we have the x value, which is 3, and the y value we can find by plugging in. So we say h of 3 equals 3 cubed minus 4 times 3 squared. So that's going to be 27 minus, let's see, 4 times 3 squared is 36, minus 36 equals negative 9. So that's going to be our slope. I mean, not our slope, our y value. So we put this right here, our slope is 3. So our point is 3 comma negative 9. So our equation for the tangent line is going to be y minus y sub 1. That's going to be plus minus negative 9. So y plus 9 equals our slope, which is 3 times quantity x minus 3. So that is the equation, or one of the equations. We could have used this negative 1/3 as well, but we'll skip that for now. Okay, next, 10. A city in Oklahoma has experienced varying temperature changes within the month of March. The temperatures, P of T in degrees Fahrenheit on various days during the month of March are given in the table below. And so it's A, and here we have this table of days versus temperature on that day. It doesn't say average temperature of the day. It really doesn't matter. Okay, A, using correct units, estimate the value of P prime of F. Show the computations that lead to your answer. Well, we have to estimate, so we're going to have to use, where is 4 located? Well, 4 is located here between the 3 and the 6. So really, we're going to be looking at kind of an A-rock situation, aren't we? We're going to look at A-rock equals f of B minus f of A over B minus A. Now, again, this is just going to be an estimate. So here we could say that 6 is our B, and 3 is our A, and f of b is going to be 75. Okay, 75. And f of a is going to be 72. And b minus a, well, that's going to be 6 minus 3. So we're going to end up with 3 over 3, which equals 1. And 1 what? Well, 1 degree Fahrenheit per day. 1 degree Fahrenheit increase per day. And then B, interpret the meaning of your answer in part A. Well, the units kind of explain that in a way, but the explanation would be for each day the temperature increases by 1 degree Fahrenheit. Okay? And C, must there be a time when P of T equals 81? Justify your answer. This is really an intermediate value theorem problem, and what we're looking for is where is 81 cross? Well, we know that to get to 81, you're going to have to get from 79 to 82. You're going to have to pass through 81. So what we're going to say is yes. And one way we can articulate this is we can say that 81 is greater than P of 11, the 11th day, and less than P of 16. And so this would be evidence that, because P of 11 is 79, right? And P of 16 is 82. So there has to be one time in there. And there's also another time, because we have this between 16 and day 16 and day 18, we go from 82 down to 79. And so we could say, and, let's see, 81 is greater than P of 18 and less than P of 16. So, yes, according to the IVT. Okay, next, 11. Write the equation of the line normal to the graph of y equals 3 over x squared at x equals negative 1. Again, what do we need for this? We need two things. We need a point, and we need a slope. Those two things will suffice. Well, the x value we already are given, which is negative 1. And we'll try to find the y value. And to do that, we'll say y of negative 1 is going to be equal to 3 over negative 1 squared, which equals 3 over 1, which equals 3. So our point is negative 1 comma 3. Next, to find the slope, we're going to try y prime. Well, first of all, y is equal to 3x to the negative 2 power And y prime is going to be negative 2 times 3, which equals negative 6, x to the negative 3 power, which equals negative 6 over x cubed. And our slope is going to be y prime of negative 1 is equal to negative 6 over negative 1 cubed, which is going to be negative 6 over negative 1, which equals 6, which equals the slope of the tangent line. Well, the slope of the tangent line is 6, and so what do we multiply to get the normal line, m sub n? What do we multiply by 6 to get negative 1, the negative reciprocal? Well, it's going to be an opposite sign and 1/6. 6 times 1/6 will equal 1. So our m sub n is going to be, or slope of our normal line is 1/6. And so now we can write our equation, and our equation is y minus y sub 1, which is 3, equals m, negative 1/6, x minus negative 1, which is plus 1. So this will be the slope, this will be the equation of our normal line. And problem 12, determine the value of k that makes the following function continuous. Use correct math notation. 3 points, okay? Again, we're talking about limit notation, so I'm going to go below here and say, and this is our critical value, 1, because the function is continuous everywhere elsewhere, because these left side and right side are both polynomial functions. So we say the limit as x approaches 1 from the left of f of x equals limit as x approaches 1 from the right of f of x. That's a minus over here. It doesn't look too neat. Okay, that's 1 from the minus side. 1 from the minus side. Okay. And to do this, we're going to say at 1, so we'll say x, which is 1, minus k, and that's our left side, and our right side is x squared, which is going to be 1 squared, minus 4 times 1, plus k. And simplifying, we have 1 minus k on the left side equals 1 minus 4 plus k. 1 minus 4 is going to be negative 3 plus k. Well, we can add k to the left side and add k to the right side, and simultaneously add 3 to the right side and add 3 to the left side, and we're left with 1 plus 3 on the left side is 4. On the right side we have k plus k, which is 2k, and so k is equal to 2. So that's going to be the value of k that will make our function continuous. No, it's not a plus or minus, it's just one value. Okay, and the last problem, which is an integral problem, trying to get students in the habit of making simple integrals even before we get hardcore into the integral portion. So what we have is the graph of from 0 to 10 of 1/2 x dx. Well, slope of 1/2 is going to be a rise over run of 1 over 2. So to go over 10, we're going to have to go up 5. Right, that's going to be a slope of 1/2. And so we're going to go all the way to here with our function 1/2 x. Y equals 1/2 x. So from 0 to 10, we're talking about this triangular area. I'm going to color in here in purple. And so we just, to find the area, we have a height of the triangle of 5, a base of 10, and so area equals 1/2 base times height, which equals 1/2 of times 10 times 5, which is 1/2 of 50, which equals 25. So our area is 25. So that's our test. I hope you did well on it, and will, by virtue of looking at this, have the opportunity better on future tests and opportunities to demonstrate your skill at calculus. Thanks for viewing.